Okay, so in this case, we're going to have our hyperbola crossing the x-axis, but it will not cross the y-axis. So we're going to have x-intercepts, one at 3 and one at -3. And remember, the hyperbola looks like two U's facing back to back. Sometimes they're back to back sideways. Sometimes they're back to back up and down. In this case, since they're crossing the x-axis, you're going to have one going this way and one going this way. Now, sometimes they open wider. You know how a U is. It could be open wider, it could be open narrower. How you figure that out, there are ways of doing it, but it's beyond the scope of this course. So you have to just look for something that looks like a hyperbola crossing the x-axis and make sure it's crossing at 3 and -3. So here was our ellipse that was crossing at 4 and -4, the x-axis, and the y-intercepts was 2 and -2. So with an ellipse, we're going to get 4 intercepts. With a hyperbola, we're only getting 2. That's why it's easier to, once you have the 4 points, it's easier to connect them and make a picture for the ellipse than it is for the hyperbola. But this is the basic look of the hyperbola. Again, if you had seen something that looked like this, where this was 3 and -3, that would have been a hyperbola that would have had to start with a y squared. It would have had to be a y squared minus x squared, because if only you look for the variables after the negative, you do not get any intercepts. Does anybody have any questions about this? Okay. So let's go on to some other type of questions that we might encounter about sections. I'm concentrating on the final work, the final 3 chapters, because I think that the final is going to concentrate on those examples as well. Okay, so I'm going to put another example on the board and give you a few minutes to try it. Okay, this is a question about a circle, and it says, find the center and radius of the circle. Remember, the circle is also a conic section. Here's the equation they give us. Our x squared plus y squared plus 6x minus 4y minus 3 equals 0. And I want you to find the center and the radius of this circle. And by the way, the circle also has an x squared term and a y squared term. But notice the numbers in front of the x squared and the y squared are 1. There's no coefficient, so it's understood the coefficient is 1. And the sign in between the x squared and the y squared is a plus. In other words, both the x squared term and the y squared term have to be positive. If this would have been x squared minus y squared, it wouldn't be a circle, it would be a hyperbola. As soon as you have a minus, one of your variables, one of your square x, or your x squared or your y squared is positive and one of them is negative, that makes it into a hyperbola. But when it's plus between them and they're both positive, it could be either an ellipse or a circle. And the way you can tell the difference is because in the ellipse, they're numbers in front of the x squared and the y squared, and those two numbers are not the same number. They're different coefficients. If they both have a coefficient of 1, then it has to be a circle. Okay, so I'm going to give you a couple minutes to work on this and see if you can come up with a solution for this. All right, erase the board over here. Okay, I think we should get started with this now. I hope you had some time to try it. If you remember, what we do is we get all the x terms together. So we write this as x squared plus 6x, and we leave a space. Then we put all the y terms together. So we have the y squared minus the 4y. And any other number, any standalone number, like this 3, has to be brought to the other side of the equation. So that equals 3. Now notice I left a space next to the x's, and a space next to the y's, because I want to use completing the square to solve this, to put it in what we call standard form. What I do is I take half of this number in front of the x. Now, if the x squared is all by itself and there's no x term, you don't have to do anything, because obviously that number is a 0. But if there is a number, if there's an x term, there's a number in front of it, obviously this is going to be, half of that is going to be plus 3. What you do is you divide it, again, you divide this number by 2 and you square it. So when you square plus 3, you get 3 times 3, you get plus 9. And you add 9 in this empty space. Now, if you put the 9 over here, then you have to over here also add 9, so that you keep your equation balanced. And therefore, this becomes x plus 3 squared, because that's what x squared plus 6x plus 9 factors into. We made this into a trinomial that's a perfect square, and now I factored it to x plus 3. If you did x plus 3 times x plus 3, you'd get x squared plus 6x plus 9. Now you do the same thing with the y terms. Again, you take half of this number, so that's -2, and you square it. -2 times -2 is +4. You add 4 to the y's, which means, again, you added 4 on the left side, you better add 4 on the right side. And then this becomes y minus 2 squared. Now, of course, there's a plus in between them. And 3 plus 9 is 12, plus 2 is plus 4 is 16. So I have now put this in what we call standard format. There's a reflection I see here. So I'm going to write it underneath. This is x plus 3 squared plus y minus 2 squared equals 16, which means that my center of my circle is the point. Remember, you take the numbers inside the parentheses. Again, if it's just a plain x squared and there's no other number there, then of course that number is 0. But in this case, it's a +3. So next, the x number becomes -3. The y number becomes +2. You switch the sign. So your center is the point -3, 2. And your radius is the square root of this number. And they'll always get you that way. They'll ask you, one of the choices they'll give you is the radius 16 or is the radius 4? The radius has to be 4 because you have to take the square root of this number. This is r squared. And that would be the answer, -3, 2 as your center, 4 as your radius. Okay, so I think we went through the conic sections. We didn't do the parabola, but don't forget, with the parabola, what's the most important thing to find out in a parabola is its vertex. So if I gave you something like this, y equals 2x squared minus 16x plus 5. And I said, find the vertex. What you have to do is use the formula x equals -b over 2a. And by the way, I am going to be sending you out a study sheet with all the facts and all the formulas. I'm going to do that today. Send you out look for it on, of course, look for it on the information page in your Blackboard account. So one of the formulas you will have is this x equals -b over a. In this particular example, a is 2 and b is -16. The a is the number in front of the x squared. If it's just a plain x squared, then the a is 1. It's called the leading coefficient. The b is the number in front of the x, which in this case is -16. And the c is the standalone number, the constant, the number that isn't connected to an x. Okay, so in this case, if we're doing x equals -b over a, we're doing -16 over 2 times 2, which gives me 16 over 4, which equals 4. Now that's not enough for the vertex. The vertex is a point, you need the y value as well. So you go to your equation and replace the x with 4, and you get 2 times 4 squared. If you want, you could put it into your calculators, but make sure you put it in with the parentheses. Minus 16 times 4 plus 5, which gives you, okay, 4 squared is 16. 2 times 16 is 32. 16 times 4 is 64 plus 5. So 32 minus 64 is -32. -32 plus 5 is -27. So your vertex would be the point for negative 27. Don't forget so if they ask to find the vertex, you use this formula, but that only gives you the x value, and you have to substitute it back into the equation to get the y value. So that takes care of the conic sections. So now I'm going to erase this because I just need the space. Let's do a quick review now of tree. Okay, so suppose I gave you this, I give you a picture that looks like this, first of all. I give you a triangle, the right triangle, and this I'm told is the square root of 2. This I'm told is 4, and I'm missing this side. See if you can figure out what the value of that side would be in simplest form. Find the third side of this right triangle. Give you a, and let's call this side. Usually we call this the A, this the B, and this the C. So we may as well do that. We know in our Pythagorean theorem, A squared plus B squared has to equal C squared. Remember, the C is always the third side, is always the hypotenuse, the one that's across from the right triangle, right angle. So this is going to be the square root of 2 squared plus B squared equals 4 squared. And when we square, remember, when we square something that's in a radical, the square root of 2 times the square root of 2 is simply 2. So this is 2 plus B squared equals 4 squared, which is 16. So I'll bring the 2 to the other side. That will give me that B squared equals 14. And that must mean that B is the square root of 14. Notice we don't do plus or minus in this case because we're talking about the side of a triangle. It can't be negative, so we only use the positive answers. So your answer should have come out to be the square root of 14. You can't simplify the square root of 14 simply because 14 only breaks up into 7 and 2, and neither of those is a perfect square. So that would have been the answer to that problem. Okay, now I'm going to give you a problem that involves a few parts. And I want you to see if you can do this example. Suppose I tell you, let's call this example 2, that the sine of A is 2 over 5. And I want you to find the following things. A, I want you to find the cosecant of A. B, I want you to find the secant of A. And C, I want you to find the tangent of A. Now, this wouldn't all be one problem. If you were getting this on your final, each one of them would be a separate problem. But I figured we can put all 3 of these together. If we can do this, and we can do any of the examples. So I'm going to again give you a few minutes to try this out. Now, so let's erase this example and look at that other example. We're given the sine of A is 2 over 5. Now, remember that the sine is, we know from our SOHCAHTOA, means the opposite over the hypotenuse. So it's the opposite over the hypotenuse. So in my example, I will take the opposite side to be 2 and my hypotenuse to be 5 because it's 2 over 5. I'll draw myself a right triangle. Let's put our A. I always like to put the A over here. Obviously, that makes this the B and this the C. My right angle. The opposite we're picking to be 2. Remember, opposite means across, so this is opposite. This is adjacent to A. Notice what's opposite to A is adjacent to B. They switch when you look at A and B, but we're looking over here at A, so this is my opposite side. Here's my hypotenuse. So I have 2 sides of my right triangle, and just like I did before, I'm going to solve for the third side of the right triangle by doing A squared plus B squared equals C squared. Remembering that my A is 2 and my B and my C is 5. So this is 4 plus B squared equals 25. And I can bring the 4 to the other side so I can get the B squared alone. I get B squared equals 21, which means that the B is the square root of 21. So this side is the square root of 21. And now I can go and start doing these examples. First of all, the cosecant. Now we have to remember, the SOHCAHTOA means sine, cosine, and tangent. Cosecant, secant, and cotangent are our secondary, or what we call our reciprocal functions. The cosecant is the reciprocal of the sine. I remember it's the reciprocal of the sine because it starts with a co, so its partner of those can't start with co. It can't be cosine because cosine also starts with co. It also starts with a C. So the reciprocal of sine is the cosecant. So therefore, the cosecant of A, this one's an easy one, is just the reciprocal of the sine, so that's 5 over 2. Even if they gave me a bunch of other numbers and they told me here's the cosine, here's the cosecant is a reciprocal of the sine. The cotangent is a reciprocal of the tangent. And the secant is the reciprocal of the cosine. So the next thing we want to find is the secant of A. Now, just as I just mentioned, the secant of A is the reciprocal of the cosine. So here's my cosine. Cosine stands for ca. So cosine A is adjacent, which is the square root of 21 over 5. Which means then that the secant of A is 5 over the square root of 21. Except you're not going to see this answer 5 over radical 21 because they basically in these type of questions want you make sure that you only have radicals in the numerator, that your denominator is rationalized. So in that case, we're going to multiply by radical 21 over radical 21, which will give me as my final answer 5 radical 21, and 21, radical 21 times radical 21 is simply 21. So the answer to part B is 5 radical 21 over 21. Finally, the tangent of A, that's our last question. Tangent is opposite over adjacent. So opposite is 2, and adjacent is radical 21. Notice once you know what the opposite, what the adjacent, and what the hypotenuse is, you can find any one of the 6 radical trigonometric functions. Again, you don't want to leave the 21 and the radical 21 in the denominator, so you multiply top and bottom by radical 21, and that'll give you 2 radical 21 over, again, plane 21. So that would be the answers. And those are the type of questions you should be prepared to ask, to answer on in terms of trigonometry. Perfect, Evelyn. That was beautiful. Okay. So now I think that pretty much goes through the type of questions you would need to know for trigonometry. So let's just do some questions that have to do with the last topic that we were talking about, logarithms. Okay, so I'm going to put a bunch of questions on logarithms on the board, and let's see if we can go through those. Okay. Example 1, I just want you to find the value of log base 6 of 36. That's question number 1. Question number 2, solve this equation. Log of 2x equals 3. Here's the third question. Log of 2x minus 5 equals 2. Number 4 looks like this. Write in exponential form. Log base 4 of 64 equals 3. And finally, 5, solve this equation. So we have a few equations. This was also a solve. Log x plus log x plus 15 equals 2. Okay. And again, I'll give you a few minutes to work on this. I'm going to pause the recording, start working on these together so we can review them. Now, actually, the one I'm going to do first is number 4. The reason I'm doing it first because all that's asking you is to switch from the logarithmic format to the exponential. And really, we have to know how to do that for all of the problems, because most of our problems that deal with logarithms can be solved if we go from the logarithmic format to the exponential. And if we remember, the way we do this is the subscript, which in this case is the 4, is the base of of our expression. Remember, we're going to exponential form, so we need a base and an exponent. The number on the other side of the equal sign, the other where it says log, just see log, forget about the numbers, the log equals. Think about exponent, where the word log is equivalent to exponent. Exponent equals 3. So my exponent is 3, so this is 4 to the 3, and that equals the number that stands right next to the word log, which is 64. So convert this expression from log format to exponential format, it gets 4 to the third equals 64, which of course is a true statement. So now let's see how that'll work in terms of solving some of these other examples. So let's take number 1. We want to find the value of log base 6 of 36. So since I don't know what it is, let's just call it some variable. Usually I call it x, but it could be any variable or any number letter that you want to call it, and switch it from the log form to the exponential form. And again, like I did before, the base is understood to be 6 because that's a subscript. The number on the other side of the equal sign, remember I put in that equal sign because I needed to re-switch its setup. That's my exponent, so 6 to the x equals 36. In other words, this is asking me, what exponent should I put on the 6 to get to 36? And we know that 6 times 6 is what gives us 36. In other words, the exponent would have to be 2. My answer would be 2. Now, if you're afraid that some of the numbers are going to be a little bit hard, that you're not going to remember if it's remember, these are multiple choice, so you can try each one of the examples. Try one, let's say they gave you 1, 2, -5, 3, until you get to the one that gives you the right number, the number that's over here. Switch it to exponential form and then just try and figure out what the exponent should be. Going to question number 2, it says log of 2x equals 3. So this is, again, this is a logarithmic equation. The only thing is that we're missing the number down here. There's no base written in. And if you remember what we said, when the base is missing, it's what we call a common log, and the base is understood to be a 10. The missing number here, it's like a square root that should have a 2 in the index, but we don't put it in because you understand when you have that radical sign, if there's no index, it means it's a square root. In other words, 2. You're multiplying the number 2 times. Again, when you have the log written without any base, it means the base is 10. So converting this again, if you notice, I'm converting this to exponential form. My base is going to be 10. My exponent is going to be the 3, the number on the other side, and that's going to equal to 2x. And I just have to figure out the solution to this equation. Well, 10 to the third, I think everybody realizes, is 1,000. So I get 1,000 equals 2x. And in order to find what x is, I divide everything by 2, and it means that my x would have to be 500. So again, switching it from logarithmic form to exponential form gives us an equation that is relatively easy to solve. Doing question number 3, same idea. It's log without any base written in, so it means my base has to be 10 of 2x minus 5 equals 2. So my exponent has to be the number on the other side. So this is 10 squared equals 2x minus 5. And now this becomes 10 squared becomes 100. So 100 equals 2x minus 5. And all I have to do is now add 5 to both sides. Now it's just a regular equation. I get 105 equals 2x. And therefore my answer, and you can leave it like this as a fraction, 105 over 2. If you see that the answer is given in decimal form rather than in fractional form, then just put it into your calculator, do 105 divided by 2, and it probably give you 52.5 or something like that. And you could also give it in that format. But this is perfectly okay as an answer. So again, we did the question by switching to the exponential form. Okay, so let's do this last question. Log x plus log x plus 5 equals 2. Again, it's a log equation, but it looks a little different than the others because we have the word log written more than once. I have 2 logs being added. And my whole idea of switching to the exponential form only works if I have the log alone on one side and a number on the other side. So we have to take this expanded version and contract it back to a single log. And remember from the rules of logs, when you're adding logs, it means that you originally were multiplying the numbers. In other words, I can go back to a single log by doing this as the log of the x times the x plus 15. So if you see a plus in between the 2 logs, you multiply the 2 expressions. If this would have been a minus, I would have divided, because when you're subtracting logs, it means that you originally were dividing the numbers. So this will give you, now we can switch this back to exponential form. Again, I don't see any base written here, so again, my base is 2. So this is 10. My base is 10, I'm sorry. Since no base was written in here, it's understood to be 10. So my base is 10. My number on the other side, the 2, is my exponent, and that equals the x times the x plus 15. And then you just have a regular equation that you have to solve. This is 100 equals x squared plus 15x. Removing the parentheses, and I see an x squared, that means it's a quadratic equation, so I have to bring them 100 to the other side, so I get it equal to 0. Let's go over here and work on it over here. So this is now giving me zero equals x squared plus 15x minus 100. And we have to factor this. If they're going to give you a quadratic equation in a log equation, you can be, I'd say, 99% certain that it's going to be something that, an easy quadratic, something that you can easily solve by factoring. So let's try this x and x. And we need numbers that multiply to 100, but when we subtract them, are going to give me 15. So that's 20 and 5. And since this is a plus 15, it's going to be, the 20 is going to be the positive, and the 5 is going to be the negative. And I said each of these equal to 0. So I get x plus 20 equal to 0, which will give me an answer of x equal to negative 20. And then I do my x minus 5 equal to 0. So that'll bring the 5 to the other side. Will give me x equal to 5. Now it looks like we got 2 solutions to this equation, negative 20 and 5. But remember, you can never have a number next to the word log that's a negative or a 0. X itself and x plus 15 can't be equal to 0. They can't be equal to a negative number. So if negative 20 cannot be used as an answer, it's what we call it an extraneous root. We've got to throw this one out because you cannot do log negative 20. If you try it on your calculator, if you press your log button and then you put in negative 20, it's going to say an error. You can't do that. These numbers always have to be positive numbers. But 5 works because 5 is positive and 5 plus 15 is 20 is also positive. So my answer is only 5. If you put in negative 20 and 5, you're going to get the answer wrong. The answer is only the 5. The negative 20 has to be thrown out. Let's just do one other type of example, and then I think we'll be finished, which also has to do with logs. Actually, it's not a log equation. It happens to be an exponential equation, and I'll remind you how to do that. Let's say I have an equation that looks like this. 7 to the x is equal to 120. It's an exponential equation because what we're looking for is, when we want to solve this, is an exponent. Sometimes it's not just a plain x, sometimes it's a 2x, but the idea is the same. And sometimes you can solve them by putting the other side, the side that doesn't have the exponent, into the same base as this side. Base being used here is obviously 7. So in order to do that, let me see where my calculator is. I'd first see 7 squared is 49. So what is 7 to the third exponent? 7 to the third is 343. There's no place when you'll get 7 to some exponent that'll come up to 120. 7 to the 2 is 49. 7 to the 3 already passed the 120. It's equal to 343. So the way we do this is by putting the word log in front of both expressions. We do log 7 to the x equals log 120. And the reason we do that is because we recall by one of the rules of logarithmetics is what I call them, or the properties of logs is, aside from when you multiply numbers, you add the logs. When you have an exponent, the exponent actually becomes the multiplier. It becomes the coefficient. Because when you have something with 2 exponents on it, an exponent on top of an exponent, what you're doing is multiplying those 2 exponents. And the log x is 1 exponent, and the log 7 is 1 exponent, and x is the other exponent. So this becomes x log 7 equals log 120. And in order to figure out what x is, I just have to divide by what the x is being multiplied by, which is the log of 7. Now, if you notice, I didn't put any base over here. That means I'm using base 10. I could have used the log of any base. I didn't have to use a base 7. I could use base 10. Any number is a base. Of course, it had to be a positive number because that's the only type of numbers that can be used as bases. But I use base 10 because I want to be able to do this on my calculator. And my calculator has a plain log button, which is base 10. So on my calculator, I press, here's what we do on the calculator. Let me just write it out. I press my log button. It'll come out something like this, log parentheses. I'll type in 120 and close the parentheses. Don't forget to close that parentheses. And I'll type in the divide button. Put in the boxes the buttons that I'm pushing. And again, I'll press a log button. And again, it'll put in the word log with the parentheses. And I'll type in the 7 and close the parentheses and press the equal button or the enter button or whatever it's called on your calculator. And when I do that, log 120 close parentheses, divide, log 7, close parentheses, enter. Of course, I get a long decimal. It's not going to come out even. It's 2, let's say they ask me to the nearest hundredth. That means 2 decimal places. So I'd write my answer as 2.46. In other words, I'm going to have to round off my answer, which makes sense because when this was a 2, I got 49. When this was a 3, I got already 343. So 120 had to be between 2 and 3, and that's exactly what it is. It's 2.46. All right, I think we are going to stop right here. I hope everything works out. Don't forget, if you cannot take the final at the given time, you must let me know in the next couple of days so I can set you up properly. Okay, have a good rest of the week. Remember, there is no class on Thursday. This was our last class. I wish everybody a lot of success in this course and in all their courses. And I hope you, unfortunately, we're still in the situation where we're going to be in remote for next term as well. I hope it works out well for you. And thank you, Darren, that you made me feel good. I hope, I know that given the situation and the circumstances, I hope that you were able to get as much from the course as you possibly can. I would have preferred meeting you all in person, but thank you, Marcus. And I know that a person-to-person relationship usually works out better, but let's just keep in touch and let me know. I hope you all have success in all your studies. Have a bye-bye. Thank you, everybody. Thank you so much, everybody, for your kind words.